Hello students, welcome back to Narayana live classes where learning never stops. So let us resume the work of assignments on the topic electrochemistry. So here let's move to the first question. So let us read the question. The reactions taking place at anode and cathode of a cell respectively are. So if you see the options, mostly as we know that one is oxidation and other is reduction, there is no relationship with the electrolysis or hydrolysis. Now, so coming to the question, so we need to say that in a respective order of first anode and second one cathode. So for your better understanding, I have just taken a picture over here. So where you can see this is an example of electrolytic cell, the cell where electrolysis occurs. So as you know very well, there are two electrodes where one acts as a cathode, other acts as a anode. And cathode is negatively charged, reduction occurs. Anode is positively charged, oxidation occurs. So it's easy to see that by visualizing the figure. But we are going to take many questions and we are going to solve many problems depending on the basic factor. So for this, I suggest you, let us go through a simple formula so that we can remember this forever. So here, I just wanted to suggest the formula what I do follow. So the formula is very simple, that whenever we are talking about oxidation, O for oxidation. So for oxidation, just remember PAO, P-A-O, positive anode oxidation. I repeat, positive anode oxidation. Now, so when I am talking about reduction, so the formula is very simple, NCR, negative cathode reduction. So with this thing we can just remember and recall it is very easily. Oxidation occurs at anode and the charge of anode is positive. Reduction occurs at cathode and charge of cathode is negative. So I think with this simple formula we can answer this question very easily. So what is that? The reaction takes place at anode is oxidation and the reaction takes place at a cathode is reduction. So what is our correct option among the following? Second option. So I think this question is clear to each and everyone. So with this I am going to the second question. Yes, let's move to the second question. The cathode of an electrolysis and a reducing agent are similar because both. So let us understand the question first. They are taking two things. One is cathode, the cathode in an electrolytic cell, and a reducing agent. These two are completely different, but what is the similarity which we have in between these two? So when we talk about that, let us just recall the same figure where I am just focusing on cathode. So cathode is an electrode where obviously reduction occurs and which is negatively charged. If you recall the half cell reaction of cathode, a metal by accepting electrons, a metal ion by accepting electrons is converted into metal, pure form of the metal. Now this is very simple, very clear that metal is accepting electrons at cathode. So metal is accepting electron. Who is providing electrons to the metal? So definitely cathode is supplying electrons to the metal. So shall I say that cathode is an electron supplier? Yes, absolutely. So here cathode is acting a job of supplying the electrons. So this is the factor. Let us suppose this particular factor I am taking supply of electrons. This is one part. And now coming to my second part. So I got a clarity about the cathode. Now I am moving to the reducing agent. We know very well what is reducing agent. Reducing agent is the element which reduces the other metal. And you know what is reduction. So again there will be a confusion in between reduction and oxidation. For this also I will give you a formula to remember. So what is reduction? Very simple to remember, GER. For oxidation, LEE O. So let me express this completely. Reduction is gaining of electrons. Gaining of electrons is reduction. Lossing of electrons is oxidation. Now I am talking about reducing agent, an agent which reduces the others. How could a metal or element reduce the other element? By giving electrons. So we can say that reducing agent is a particular element which gives electrons or which supplies electrons. Am I right? So when I talk about cathode in electrolysis and also the reducing agent, I got a common factor that is nothing but supply of electrons. So among the given options, they are metals, they can supply electrons, they can remove electrons is wrong, and absorb electrons is also wrong. So what is the correct answer here? Both can supply electrons. Cathode and also the reducing agent, they are having a common property or feature, they are supplying electrons to the other metals or non-metals. So I think it's clear. So let us move to the third question. Yes. Here we go with the third question. A schematic diagram of an electrolytic cell. So for answering this question also, so let us see the same thing, whatever the formula we have used, so that will definitely help in answering this particular question. So diagrams are already given, you need to pick the perfect picture which is showing the electrolytic cell. So you know already, so there are two electrodes, one is anode and one is cathode, that knowledge we have. So let us see, this is cathode. Yeah, let's check. For example, this is anode. Okay, so what could be the charge of anode? You remember which formula we use? PaO. Now tell me, what is the charge of anode? Positive, right? So let us suppose this is positive. And what is the charge of cathode? Definitely negative. Now, so cathode, what are the ions which are attracted towards positive pole? So definitely the ions must have negative charge. If you observe carefully, here the positive charge or cations are getting attracted to the positive pole. Are you agree with this? So definitely it's wrong. So let us eliminate this option. Okay, so let's move on to the next option. If you see here, same formula, anode is positive. Okay, now here we are having anode, this is, let us suppose, positive. So cathode will be definitely negative. So what are the ions which are attracted by cathode? Definitely negative ions. See, so negative ions are getting attracted towards anode. And now coming to here, the positive ions are getting attracted towards the opposite pole. So can I say this is the right option? Absolutely, this is the right option. So by using the same simple opposite poles attract each other with the same phenomena, we can answer to this question. Now coming to the third question. Yes, so direct conceptual question we got here. Let's see the question. Electrolytic conduction depends on. So what is the factor or what are the factors on which electrolytic conduction depends? So you know the factors already. So let us check one by one. Nature of electrolyte. So does nature of electrolyte have any kind of influence on the electric conductivity? Definitely. As you know very well, there are two types of electrolyte, strong electrolyte and weak electrolyte. More the stronger, more will be the ionization and definitely more will be the conductivity of electricity. So I have to accept this option. Your nature of electrolyte is a right option. Right? Now coming to the size of ions. So you know definitely the electric conductivity depends on the size of ions. You know, lighter ions will move faster. Definitely there will be the conductivity more, and huge ions or larger ions, the conductivity will be less. So more the size of ions, lesser will be the conductivity. We can take an example like for example when I consider only first group, so lithium ion, the conductivity of lithium ion will be larger than the conductivity of cesium ion. This is the order. So now coming to the third, concentration of electrolyte. Yes, this is one of the factors which also influence the electric conductivity. So we have concentrated solutions and also diluted solution. So concentrated solution means there will be a much more concentration of acid or base or whatever the electrolyte. So ionization mode, which increases the electric conductivity. So with this I can frame a sentence, more the concentration, more is the conductivity of electricity. So I have to take an option, all the above factors which can influence the electric conductivity in electrolysis, right? With this, let's move to the next question, or mostly this is the final question. Here we go. In electrolysis of NaCl, when platinum electrode is taken, then hydrogen is liberated. So this is one statement. Now, when hydrogen is liberated at cathode, while with the mercuric cathode, it forms sodium amalgam. So give me the reason. So see the question clearly. In both the cases, there are two cases. In both the cases, NaCl is an electrolyte. In first case, platinum is acting as a cathode, and in other case, mercury is acting as a cathode. In first case, we are getting hydrogen because in the solution, we can say, like when we talk about this particular solution in a beaker or in a cell, we are having the ions like we do have sodium plus Cl minus and also hydrogen. So whenever you are having platinum electrode, so what's happening? Hydrogen is getting deposited on platinum electrode, and finally we are getting hydrogen gas at the cathode. But now coming to the second case where we are having mercury. So what happens actually? So as we know very well, the hydrogen over voltage of mercury, so due to that reason, hydrogen allows the other higher or heavier ions to get deposited. So that is the only reason, and we need more power or more reduction potential to get hydrogen deposited on mercury. So due to that reason, usually actually hydrogen should go and deposit it, but here sodium ions will get deposited on mercury, so that we will get sodium amalgam as a product. So we can say as more voltage is required to make hydrogen get deposited on mercuric electrode, so that's the reason we will get sodium amalgam as a product. So this is the answer for the last question. All these questions are very simple, but they are very important. So let's go through that. So let us see what is the right answer. More voltage is required to reduce hydrogen at mercury compared with the hydrogen deposit on platinum. So this is the right answer. So thank you so much for being a good listener. Stay home, stay safe. Thank you.